See, we are solving the problem that is analyzing the problem on the trusses by the method of joints. So, this is what the another different problem we are going to analyze. You just observe this, whatever the truss it is given. So, this is statically determinant stress. So, first thing is you need to determine the support reactions. So, hinged support is there. We are having the two reactions, one is horizontal and another one is vertical, and roller support we are having only one vertical reaction. So, as we know, so first thing is you need to apply the some equilibrium condition for the entire truss, that is summation of horizontal force is equal to 0. So, since the horizontal force is only that is one force, there is no any other horizontal forces are there. So, therefore, Rax is equal to 0 is nothing but what? This force Rax is 0. Similarly, you need to apply the summation of vertical force is equal to 0. So, vertical force means you just observe in the truss, Ra is a vertical force moving upward, therefore it is positive, plus Re is moving upward, that is positive, minus the point forces, that is point load which is acting on the different joints, that is H, G, F. We are having the different point loads are there, minus 30, minus 20 and minus 30 is equal to 0. So, now this is what the summation of vertical force. You can get an equation Ra plus Re is equal to, so you will get At. This just consider it as a equation 1. So, now what you need to do? So, you need to determine what is the reaction Ra and what is the reaction Re. So, therefore, you need to take the moment at A point, that is the third equilibrium condition, summation of moment at which point at A point is equal to 0. So, moment due to this Rax and Ray become 0 because these are all acting at the same point. Moment due to other forces you need to consider about the point A. Just I am considering the moment due to this 20 kilonewton. The 20 is a force into perpendicular distance clockwise, 30 again force into perpendicular distance, this is also clockwise, this 30 is also clockwise. Just I will write the moment due to the 20 kilonewton, 20 is a force, right, and perpendicular distance is 3. Direction is clockwise, therefore it is positive. And moment due to this 30 kilonewton, 30 is acting at point G, perpendicular distance from G to A is how much? 6 it is. So, therefore, 30 into perpendicular distance is 6, again clockwise, positive. Similarly, another 30 kilonewton is acting, 30 into the total perpendicular distance is 9. So, that we have already considered. So, next another force is there, that is support reaction Re. What is the moment of this Re about point A? What is the moment of Re about point A? Just observe the figure.
Re into 12.
So, Re into 12, and in order to reach the point A it should come like this, that is in the anti-clockwise direction, therefore it is negative, this is equal to 0. So, in the entire equation you just observe only Re is unknown. By simplifying we are getting the value of Re. So, that is 42.5 kilonewton. So, you just check it once. So, whatever the value you are getting by the simplification. So, this is what the Re value. So, we are having the equation 1, Ra plus Re is equal to 80. Just substitute that, you will get a value of Ra as a 37.5 kilonewton. So, this is what the support reactions Ra and Re of the different supports which is acting on the different support provided for the trusses. So, the first step is over, the calculation of the support reaction. So, now the thing is, this is what the analysis of truss by the method of joints. We need to consider each joint and we need to apply the equilibrium condition here. So, and joint should be considered such a way that there is a maximum of 2 unknowns, clear. So, because at the beginning it is not possible to consider this joint E. So if you consider joint E means we are having the many unknowns here, 3, 4, 4, 5 unknowns are there. We cannot solve it by considering the 2 equilibrium condition. So therefore the joint should be chosen such a way that there is a maximum of 2 unknowns. So therefore I am going to consider the joint A first, that is consider joint A. Similarly, so what we have discussed in the previous problem, we need to write the free body diagram of joint A. Just I am writing, if it is a point A, AH is a axial force and AB, right, and one support reaction is there, that is what the support reaction RA, and another AH is the member force that is acting in terms of tension. We need to assume that initially the whatever the forces which is moving, which is away from the joint, so that is we need to consider it as a positive. So if we are getting the value as a negative, then it indicates, so whatever the axial force we are considered, so that is in the compression. So and similarly here also you need to find out the inclination of inclined members. Same thing, here different inclined members are there, just I am highlighting. So here the vertical distance is also 3, this is also 3. So you can find out theta is equal to, so theta is equal to, so you just apply the trigonometric function tan inverse of 3 by 3. So we are getting the theta value as a 45 degree. That is inclination of any inclined member with respect to horizontal or vertical, it is 45. So because if x axis it is 45 means here also this angle is also 45. So therefore the inclination is 45. So just I have written the free body diagram, inclination is 45 degree. Just I will write the member forces, this is TAH and this is TAB and this is the support reaction, that is RA. You need to consider RA. So RA is how much? That is 37.5 is our RA value. So now for this joint we need to apply the equilibrium condition. So just apply the equilibrium condition. First, summation of horizontal force is equal to 0. You need to follow the sign convention, this is positive, this direction, this is negative and this is negative, same sign convention. So just observe here, just I have considered the joint A, AH is in positive direction, so therefore it is positive TAH. Horizontal force I am writing. So now we need to resolve this, right? One inclined force is there, right? TAB cos 45 is a horizontal, the resolved horizontal force, and TAB sin 45 is a vertical component, because 45 degree is an inclination with respect to x axis, x component is cos, y component is sin. So which component I am writing here? I am writing the y component. So therefore it is moving downward, therefore minus TAB sin, so minus TAB, just I am writing the horizontal component, so that is cos 45 is equal to 0. So here TAH is also unknown, TAB is also unknown, so we are not getting. So just go for the next equilibrium condition, summation of vertical force is equal to 0. Clear? So vertical force RA which is moving upward, therefore 37.5 is the value of RA, this is positive, and minus vertical component TAB sin 45 is equal to 0. Clear? So by solving this, because TAB is only unknown here, TAB is equal to, just take this on the right hand side, and by simplifying we are getting the value, that is 53.03 kilonewton. So since it is the positive, therefore as our assumption is right. So whatever the member TAB, that is in the tension, 53.03. So just substitute this 53.03 in this equation. right? You will get the value of TAH. By substituting the TAB value, you are getting the TAH as a minus 37.5 kilonewton. So since it is negative, so you need to mention the member is in compression. Clear? So now TAH is over, TAB is over. So I have considered the joint A and TAB and AH. So this member and this member I have calculated. So now the thing is, you need to consider the next joint. So how we need to consider? The unknown should be minimum. Just observe the figure. So if you are considering, suppose if you are considering joint B now, what happens? TAB is known, this is we have calculated, but these three members are unknown. BC is unknown, BG is unknown and BH is unknown. But as per our theory, we want only the two unknowns at the joint. So suppose, therefore it is not possible to consider this joint B. So next I am going to consider the joint H here. So why? We are already calculated the member force AH, this is known. Only unknown is HG as well as HB. Two unknowns are there. So therefore the next joint after A, I am going to consider the joint H and I am going to write the free body diagram. Just I will show the what are all the member forces which is acting. That is HA is there, HG is there. Away from the joint only you need to show the direction. HB is there here, this one, and another vertical force, point load is acting 20 kilonewton. So that is 4 forces you need to show at the point H as a free body diagram. Just I will write here the free body diagram about point H. You just observe. So this is what the free body diagram of joint H. So one force which is coming downward 20 kilonewton and another member force, this one, and another member force is there. Whatever the member force I have shown, the same thing I have written as a free body diagram. This is 20 kilonewton, right? And this is THG and this is THA and this is THB. So just observe here, right now we have calculated the value of TAH, right? You just observe, this is minus 37.5. Just I will write the value here, minus 37.5. So 4 forces, this is in the form of coplanar concurrent force system, right? Which joint it is? It is joint H I have considered now. Coplanar concurrent force system is there. 2 unknowns are there. We can find out it. Just we need to apply the equilibrium condition, summation of horizontal force is equal to 0. So in this joint we are not having any inclined forces. So all are horizontal as well as vertical forces are there. So horizontal means THG is there, that is in the positive direction, THG, and THA. So this is very careful, you need to consider here, because our sign convention, this is positive and this side negative. So THA is already in the negative direction, first write it as minus. THA value we know that is the whatever the member force of THA, that is minus 37. You just put in bracket minus of minus 37.5 is equal to 0. So these conventions are very important, otherwise it will changes the compression as well as tension sign. So while substituting that, you need to consider which direction force is acting. This is already negative direction, but our member force we have obtained the value of minus 37, therefore minus of minus you need to write, right? So this will become plus now, but if you are taking on the right side, what happens? THG is equal to, that is minus 37.5. So the minus into minus plus, if you take on the right hand side, again it will become the minus. So since it is a minus, therefore it is compression. See, while substituting and solving, the case should be taken, so whatever the direction of the force is there and the magnitude of the force, so that is also very important. So, and another equilibrium condition, summation of vertical force, only one vertical force, two vertical forces are there, 20 kilonewton coming downward, minus 20, and THB is also moving downward, minus THB is equal to 0. So, if you take THB on this side, what happens? Again THB is equal to minus 20, again the negative sign indicates the force is in the compression. Clear? So, this is what the force that is in the compression, joint H is over. So, now I will come for the again for the figure or the truss. You just see here. So, now the member forces, which member forces? This is known, this is known. Again next joint we need to consider such that it should have the two unknowns. So, now I can consider the joint B, because AB we have calculated, B H I have calculated, unknown is BG and BC. So, now I can choose the joint B for the application of the equilibrium condition, because only two unknown, TBG is unknown, TBC is unknown. So, therefore, I am going to consider the joint B now for the application of the equilibrium condition or to determine the member forces. Just I will write the free body diagram of joint B, joint B. Just observe here, joint B is there. Just I will write the highlight what are the member forces, TBG, this one, BC, right, and BH will come away from the joint, and AB. So, this is what the simple free body diagram of joint B. The same thing I am going to write, just concentrate here. So, joint B, I have considered the point B here. From this BC is moving, BG is moving, BH is there, and AB is there. We need to write the magnitudes, just I will write. This is TBC, TBG, THB or TBH, TBA. Again inclination is 45 degree now. So, here unknowns are TBG, TBG unknown, TBC is unknown. These two are the known things. TBH we are having the value here only, minus 20, just I will write minus 20. So, and AB we have calculated. So, the AB value is that is 53.03 positive value. Just observe here we have already solved TAB 53.03. Just substitute that value. So, this is again ready, that is B point coplanar concurrent force system. Just we need to apply the equilibrium condition. So, very simple, but which joint you need to consider first, how many unknowns are there, and the direction of the axial forces which is acting, and whatever the magnitude you are obtained for the previous members. So, the writing of the magnitude, that is very important. The rest of the thing is similar what you have done the different problems on the coplanar concurrent force system, the same thing. So, now joint B free body diagram is ready. We need to apply the equilibrium condition. Summation of horizontal force is equal to 0, summation of vertical force is equal to 0. Just I will consider summation of vertical force is equal to 0. So, minus 20, it is upward, therefore, our convention is positive, but the value is negative, that is minus 20 is one vertical force, and we are having the two inclined forces here. So, this inclination is also 45, same thing. So this is we need to resolve, this force also we need to resolve. Two inclined forces are there. Just I will write the BG first, both are moving upward, plus TBG, 45 with respect to x axis. So therefore TBG sin 45 is our vertical component. Similarly, plus TBA sin 45 is the vertical component of another inclined force. This is equal to 0. TAB value is known here. TAB or BA is how much? It is 53.03 is there. Substitute that value. If you substitute the TAB value, only the unknown is TBG. So we can easily obtain the value of TBG by simplifying this. I am getting the value of minus 25 kilonewton. Since it is negative, therefore it is in the compression. Now consider summation of horizontal force is equal to 0. Similarly, TBC, this is in the positive direction, and this is positive and this is negative. Directions you need to consider, plus TBG cos 45 and minus TAB cos 45 is equal to 0. TBG we have calculated, only the unknown is TBC here, because TBG value we have and TAB value we have. You just substitute that, only the unknown is TBC. So just I will substitute TBC plus TBG is nothing but minus 25 into cos 45 minus TAB. TAB value is 53.03 minus 53.03 cos 45 is equal to 0. So in the entire equation, only the unknown is TBC. By applying, by calculating this, you are getting the value of TBC is equal to 55.1 kilonewton. So that is the TBC value, that is positive, therefore it is in the tension. So this is what the equation, TBC is in tension. So now joint A is over, joint H is over and joint B is over. The remaining member forces also you need to find out by considering the different joint. So just I will consider the another joint, that is joint C here. Just wait. So this is joint C, you just observe, just I will highlight with a different color. So if you consider joint C, BC is known, CG and CD are unknown. So we can easily find out the two unknowns here. BC we have already calculated by considering the joint B. So if you are considering joint C, we can easily find out the value of CG as well as CD. So this is what the free body diagram. So whatever the yellow color line I have indicated, so this is the free body diagram at the joint C. The same thing I will write the free body diagram at joint C. Which joint? That is joint C. So what is the free body diagram? This is what the free body diagram of joint C. So this is TCG and TCD and this is TCB or BC. This is 55.1. Just now we have calculated 55.1. Very simple is there, only three forces are acting. Summation of horizontal force is equal to 0 means you will get TCD minus 55.1 is nothing but TBC is equal to 0. By this TCD is equal to 55.1, that is positive tension, right. So after that, summation of vertical force is equal to 0. Only one vertical force is there, that is TCG, and we are not having the another vertical force, that is equal to 0. So TCG now it is becomes 0 now. So now at the point C we have obtained the two unknowns TCG as well as TCD. See, one more thing I need to inform you. You just observe the whatever the truss which is given. So if any straight line or the members are collinear members are there, the third member, if it is simply resting on this collinear member, and at this joint if there is no any forces are acting, then this member force will become 0. What it means? So if we are having any two forces, this one, these two forces are collinear. If you are having the another member which is simply resting, such that at this joint if there is no any external forces are acting, automatically this member force will become 0. That is what the concept we are having. The same thing now by calculating also we have obtained this member force as a 0. So still now, so we have calculated the member forces up to the joint C. So we are having the remaining members also. So we can find out the what is the value of the member forces of the axial forces which is acting on the different members. So we need to calculate. So let us continue that in the next class.